Looking at types of energy, there's 3 types we're going to use in this course, and we're going to look at what they are, look at the formulas for them, and see an example. Okay? So the first one is kinetic energy, and we've talked about this already, but it just, in the way I would word it is the faster something moves, the more kinetic energy it has. Just quite simply. Okay? The symbol for kinetic energy, usually it's capital E with a little K on it. Sometimes, maybe out of my laziness or maybe the textbook, I don't know. But sometimes I'll just say KE for kinetic energy. The units for all energies is joules. That never changes, same as work. Excuse me. And here's the formula. Okay, 1/2 mv squared. So m is mass, it has to be kilograms. Okay, that's really important that you know that it has to be kilograms. And v has to be meters per second. So speed in meters per second. And you can see here I put already the rearranged form. Okay, so if you're looking for speed given kinetic energy, this is what you use. Okay, so just look at my example. Again, if you need to pause, please do. So Eric Orna has a mass of 95 kilograms, and we want to find his kinetic energy if he's running at 8 meters per second. So we know his mass, we know his, oh, that's a typo on my part. It's not 8 seconds, it's 8 meters per second. We know his speed. All you do is substitute into the formula, plug it into your calculator, 3040 joules. That's how much kinetic energy he has. Okay? So as long as it's not like work, it's not saying that's how much he's burnt, so to speak. It's just saying at that moment, that's his kinetic energy. Sometimes you go backwards, and that's why this formula. For some reason, we know the Lord of the Eagles, he's got a mass of 75 kilograms, which is really about 10 times bigger than a regular eagle, but I guess they're huge, right? And while in flight, his kinetic energy is 15,000 joules. How fast is he flying? So you can just see by looking at it, I know the kinetic energy this time, I know the mass, I want to find V. I use that rearranged form. Make sure that the square root is over the whole thing. So you do the whole bit in here in your calculator. 2 times 15,000 divided by 75, that's what you do first, and then take the square root at the end. 20 meters per second, which actually is a fairly, I think, I'm going to circle that, a fairly reasonable number for a speed for an eagle. What's that, times 3.6, so about 75 kilometers per hour. Okay, so the second, again, pause if you need to, I'm moving on. The second type of energy is gravitational potential energy. Okay, and this is, the higher something is, the more gravitational potential it has. And again, this is the idea of the Leviathan. It's at the top there, and it's got tons of energy, right? And as soon as it's allowed to drop, it'll speed up, and it'll gain kinetic energy. It'll lose gravitational and gain kinetic. So the symbol for gravitational is E with a little g, or sometimes just GPE, depending on how I feel. Okay, the units is J for joules, and there's the formula, mgh, which might look familiar to you. Because yesterday, in the last video, I asked you to find work, and I said the work to lift something was mgh. It's the exact same. Because the work that you do to lift something overhead is strictly transformed into giving that object gravitational potential energy. So it's work, which is motion, transferring to a gravitational energy. Okay, so the things that we know is the mass, the g is always 9.8, and the height of the object. Make sure you deal with meters and kilograms, and it's all good. So we'll do an example with that. Frodo hovers above the fires of Mount Doom. He's 26 meters above the fire, so there's my 26. What is the gravitational potential? The 35 kilograms was from a previous example. I must have had that written down. Okay, so you just turn around, calculate it. 8,918 joules, which, I don't know, looks like a good number for poor Frodo above the fires there. Good thing he didn't fall. Okay. Just a note about H. This is kind of weird, but it's the idea that it's the relative height. So we always measure gravitational potential between two objects. In the, if you took a second course in physics, we do gravitational potential energy in general. And when you do that, then you're looking at something completely different. But for this one, we're saying that you're comparing the gravitational potential energy. Usually it's for an object and the surface of the Earth. But it could be, for example, for standing in the classroom, when you have a tennis ball over your head and maybe it's 3 meters above the ground, right? Well, the ground isn't the surface of the Earth. The ground is the floor in the classroom. So the height you would use would still be 3 because that's where it's going to hit the ground, right? but you wouldn't use, all the way to the Earth, right? You just use the amount it can drop. Okay. If you have if you're comparing two objects, you say, well, the lower object has a height of 0, and the higher object will have a height of the difference between the two. And you'll just see that as we get into the roller coaster type questions. Well, to give you a roller coaster as an example, when we calculate gravitational potential energy of a roller coaster, Leviathan or something, the height that you use is the height from the top of the first hill to the bottom of that hill. Not to the ground, which is probably a good 7 or 8 meters below the bottom of the roller coaster track, right? But you do from the top to the bottom, like where it's going to actually move. But we'll see more examples of that later. Our third type of energy is thermal energy. And this is very specific. There's different types of thermal energy, and we'll get into that. But this one is specifically energy loss due to friction. So we give it the symbol ETH for E thermal, units of joules, and it's FK delta D. Okay, so it's actually the same as the work loss due to friction. Negative, remember the negative work due to friction, right? Same thing, except for it's not negative in this. Okay, so it says Legolas slides along the ice way up high in the Misty Mountains. He slides for 20 meters against a frictional force of 10 newtons. How much of his initial kinetic energy is lost as heat? So we always think of thermal energy as lost to the system. It's not lost to the universe, but it is lost to Legolas, right? Or if it's a roller coaster, it's lost to the roller coaster. It becomes wasted energy. Anyways, the calculation is very simple. It's the friction force times the distance. Just sub in and solve, okay? I think it's a good number, about 210 times 20. Really can't screw that up. Okay, one last thing for this lesson is something called the work energy theorem, which says that work is equal to the change in kinetic energy. So how much kinetic energy you give something is a measure of the work done. And so the formula just looks, this is the ultimate formula here. I'm just saying change in always means the second condition minus the first condition. Going back to grade 9 calculating slope, you looked at the change in y over the change in x, right? And you take y2 minus y1. Well, it's the same thing. It's ek2 minus ek1. And so just, you don't need to worry about this line so much, but this in the green is the formula you care about. So this is a formula for work now that I didn't show you yesterday just because I wanted to talk to you about energy first. Okay? So now we have another formula for work, and let's apply it. Legolas accelerates from 2 meters per second to 12 meters per second as he runs to chase after the orcs, okay? And we want to find out his work done. So how do you know when to use this formula? Well, if you're looking for work and you're given two different speeds, probably this is the one to use, okay? So we know the mass, we know the two speeds, we want to find work. It just is a sub in 1/2 times 55, you 12 squared minus 2 squared, because it's V2 minus V1, so it goes from 2 to 12, and just calculate it, okay? Oh, that's a weird one. Okay, so I think that's it. Yep, that's it for this lesson on kinetic energy, gravitational potential energy, thermal energy, and just reviewing the work energy theorem. Okay?